Let's look at the basic control structures in Matlab, specifically those of repetition and selection. But before we do that, let's get some terminology out of the way. Whenever we say we're dealing with a scalar in Matlab, effectively we're dealing with a number or an entry. And since we're saying arrays are the basic types, so we're going to think of a scalar as a one-by-one array, all right? And when we say we're dealing with a row vector, we're dealing with an array that is 1 by m, that has one row and let's say m columns. And when we're dealing with a column vector, we're dealing with an n by 1 array. So it's something that has n rows and 1 column. And when we say we're dealing with a matrix, we're talking about a regular table, an n by n array. So something that has n rows and n columns. So let's take a look at an example in here. X is a scalar, it is equal to 9. Y is actually a row vector that is 1 by 10, and you can see it in here when we display it. We didn't put the semicolon, so it is displayed. It is 1 by 10 ones. Z, on the other hand, is a column vector, and this is 9 by 1. So 9 entries, 9 rows, and 1 column. And we used in here the rand function. Rand function is a function that's in Matlab that will generate a random number uniformly between 0 and 1. And we're going to talk a bit about it later. And if we write rand for 5, we're generating a matrix, a regular table that is 4 by 5, 4 rows by 5 columns, random numbers between 0 and 1. And when we write whos, we're going to see all the variables that we have currently in the workspace. There's some stuff that we've seen from before that is still remaining in the workspace in here because I didn't clear it. How about the repetition structure 4? Well, the 4 structure is very similar to Matlab. It has the following syntax. It has an iterator or a counter, let's say, and it has an iteration range, and this is specified as an array. So we write for I equal, and we give an array. Now, this means that I will take the values in the arrays. Actually, it will take the values 1 column at a time. So if the array is 1 row, a single row, then this is going to take the first value, the second value, etc. But if the array is actually 2 rows, it's going to take the first column, the second column per iteration in here. And there's the loop body. The loop body is not defined through indentation, even though visually it will make sense to indent the block. So we allow whoever is reading the code to understand it a bit better. It is allowed, it is specified by a sequence of statements that are between the for syntax and the end. So the for loop does end with a keyword that is end. This is the body of the for loop. So let's take a look at an example. We would like to compute the sum of numbers from 1 to 10. Originally, we assigned the value 0 for the variable sum. So we're declaring a variable sum. We're saying it is equal to 0. And here's the for loop. So we write for I equal. And here we're specifying a range. We're specifying an array. Actually, we're specifying the array 1, 2, 3, etc., all the way to 10. And within the body of the for, we are going to add to sum the value of I. And here's the end. We need to have the end to dictate or determine where is the body of the for loop. And finally, we're displaying the sum in here. So we're going to go ahead and run it. And the sum is 55. Now, just to see it a little bit better, let's say that we want to sum only the odd numbers. So here's an array A, and it contains only odd numbers indeed. So this is the syntax that we've seen before. So the first value in the array is 1, and then we're jumping by 2. So A is going to be 1, 3, 5, 7, 9. And after that, it is the same syntax. We're going to say the original value of sum is 0. But then for J in array A, so we can see if I hover over A in here, I didn't execute it yet. So what J is going to be for J in A, we're going to sum plus J, and we're going to display the sum. And let's do it now. And the sum is going to be 25. And you can see if I hover over A is 1, 3, 5, 7, 9. All right. So for, it takes an iterator, equal, it takes an array, and the body of the loop will be executed for J taking the first value in the array, the second value, the third value, and first, second, third are referring actually to columns. So let's see that in case I have an array in here. So I'm gonna execute this code. I have an array in here that is 2 by 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so this is the array that we are dealing with. If we write for j equal a, we're going to be iterating. On the first iteration, j is going to be actually one column, it's going to be 1, 6. And then on the next iteration, j is going to be 2, 7. So if you want to do the total sum to 10, so we're going to be summing sum plus j of 1, j of 2. And then at any iteration, j of 1 is the first entry, j of 2 is the second. And when we executed this, we saw that in the beginning it was 7 because we didn't put the semicolon, which means we're displaying the result of this execution of the statement. So 7, next round 16, after that 27, 40, and 55. All right. So the important thing to note in here is that we are iterating over the columns. So one column at a time. It just happens that sometimes we have only one row, so the column is actually one number. But in case I have multiple rows, the j and the iterator is actually the whole column. So this is a way of, or this is what we needed to illustrate how the for loop works. There are some useful functions that may come in handy when you're looking at arrays in general. There is the notion of the size. When you write size of and parentheses of array, it will return to you the number of rows and columns. So it will specify what is the size in terms of number of rows, number of columns. Now there's the notion of length. Now length will return the larger of the two. I mean, usually you would ask or would like to figure out what is the length of a one-dimensional array. So if it is a row vector, it's going to give you the number of columns. If it is a column vector, it's going to give you the number of rows. But in general, if it is not one-dimensional, it will look for the larger of the two dimensions and it will return the larger of the two. So this is the function length. We've used the function rand. Rand is a function that will generate uniformly distributed numbers between the value 0 and 1, and we can specify how many of those we want. We've seen the function plot, and today we're going to also see the function surf. Surf is going to be used to plot 3-dimensional curves versus a plot that is used to do 2-dimensional curves. So let's use some of those functions and some specific examples. So I would like to plot sine of x divided by x. So first, let's generate the data. So we're going to take 100 numbers, and we're going to start by saying the function, I'm filling it with zeros, one row and columns, and at some point I will compute it next. And here we go. These are the x's over which we're going to compute the sine x over x. So we're going to use linspace. We're going to go from minus 5 pi to 5 pi included, and we're going to generate n numbers that are equally separated between minus 5 pi and 5 pi. And here, and we're taking 500. These are the values on the x-axis. And then we're going to compute the value of the function. So here we go. We would like for I from 1 to n, we compute sine of xi divided by xi. So this is the sinc function, sine of x divided by x. Okay, now, since we're dividing by x, we'd rather not have x equal to 0. So here's the, within the for loop, we're going to use a selection structure. We're going to say, okay, if x is 0, if x of I is 0, then, you know, L'Hopital rule, if you'd like, or whatever you like, Taylor series expansion and sine. So sine of x is roughly x divided by x is 1. So when xi equal to 0, we're going to put f of I equal to 1. Otherwise, here's the else in here. So we know if else and structure. Otherwise, f of I is sine of xi divided by xi. All right. So this is, we're going to do this from I equal 1 to n because the size of x is it's linspace. It is one-dimensional array of n numbers. And here we're going to plot xf. So we're going to execute this. It's going to take some time to compute. And here it is. So this is the sinc function, sine x divided by x. As you can see in here, x goes from minus 5 pi to 5 pi with 100 numbers that are equally spaced in between. This is how sine x would look like. Now, what if you would like to plot sine x times sine y? So it's a 2-dimensional plot. Okay, let's generate the data for that. Okay, what do we want now? We want for every x multiple values of y's, specifically n. So let's start by generating zeros, n by n zeros, and then we're going to fill the data. We're going to say I is going to go from 1 to n, j is going to go from 1 to n. So these are two nested for loops, and we're going to compute the sinc of I, the function we have out there, f of I, and we're going to multiply this by the sink of j, which is f of j, and we're going to do g of ij is f of I times f of j. And here we have two-dimensional functions. The first index is gonna describe the entries that are in x. Now f of I we did compute, we did plot f of I, right? So this is the graph of f of I. Okay, I is gonna be a number between minus 5 pi to 5 pi, etc. And we're gonna multiply by f of j. To plot it in here, we're using the surf function. The surf function takes the x's. Now it just happens here that we're going with the same y, right? And x is equal to y. So from minus 5 pi to 5 pi. And we're plotting g. And let's go ahead and do that. This is going to be a three-dimensional plot, and you can see it in here. You can actually rotate the plot if you would like. Look at it from below. Now you can zoom. You can move it. It is developed software. It is a developed package by MathWorks. It is not free, but you do have the license, student license. If you are on camp, if you ask the IT department, they will install a student version for you. And it has very powerful tools. And here we're showcasing a few of those when it comes to plotting. So this is when it comes to the for loop, to plotting two-dimensional and three-dimensional curves. Here's another, or the second repetition structure we've seen in Python. Here it is very similar. It is the while loop. So the syntax is the same, while a Boolean expression. And if this expression evaluates to true, some statements will be executed. The only difference with Python is that it's not, the block of statements is not defined by indentation. It has to be between while and the keyword end. Right? So it is the same concept, and simply the syntax is slightly different. Of course, in Matlab, we don't have to put a colon after while. We simply have to write the expression. Potentially, the statement's going to put semicolon afterwards in order to avoid echoing. The selection structure, if and we've seen it, if else we've seen it. How about, do we have something similar to nested or multiple if else structure? Yes. Here we will have if, else if, else. So else if is one word, and this is going to be, we write a condition in here. If the condition is satisfied, some block of code will be executed. This is the block between if and else if. Else if, it is effectively similar to this, right? But there's no point of putting the space, so we write else if in here. And here's another expression. So if the first expression 1 is false, the expression 2 is checked. And if expression 2 is true, then a block of code will be executed and we're done. If expression 2 is false, then expression 3 is checked. In case true, a block of statements in here will be executed, and the block is defined between else if and else. And here, this block will be executed in case expression 1, 2, and 3, all of them ended up being false. So this is the selection structure. If, else, we've seen if, else, end, and here if, else, and end.